In this video, we are going to learn about what it means for a function to be one-to-one. Okay, so let's go back and remember what the definition is of function to start with. So a function takes a domain value and maps it onto exactly one value in the range. What that means is every x value, like this 2 right here, maps to only one y value. 2 doesn't go to this value and also some other value, right? Same thing for -2. It goes only to this one y value. It doesn't go to that value and some other value. Every x maps to only one y. And you remember how we would check for this when you guys first learned how to do it. We would do the vertical line test, and we would do a vertical line across it over and over. And if it passed the vertical line test, then it was a function. So in this video, we're going to look at one-to-one functions, which are a special type of function. It's still a function. Every one-to-one thing is already a function, and we're going to check if that function is what we call one-to-one. Okay, so let's get a definition. One-to-one means that no two elements of the domain correspond to the same value in the range. Basically, that means none of the range values, none of the y values are repeated. So for just being a function, none of the x values are repeated. Every x value goes to only one y. For one-to-one, it's the opposite. None of the y values are repeated. So look at this y value right here. Do you see I have the same y value over here? This y value of 2 came from two different x values, a little bit more than +2 and a little bit less than -2. So this function is not one-to-one. So the way we're going to check this, because the definition of one-to-one is essentially like backwards of the definition of the function, you're checking to see if any of the y's are repeated. So the way we're going to check this is with the horizontal line test. And you can see that my horizontal line over and over, it's crossing two different y values. It's crossing here and here. It's crossing here and here. So this y value is repeated. It comes from two separate x values. So this function is not one-to-one. Okay, so how about this one? Let's see if this one is one-to-one. Is every y value different? All right, let's put some horizontal lines on there just as a test. All right, and you can see that every time my horizontal lines only go through one y value. Now right here, it gets a little tricky. If I put one right on the axis, it looks like it is flattening out on the axis, and it looks like that it goes through more than one right there. But that's just because of the limitations of our technology. In reality, if we could zoom in, zoom in, zoom in, you would see that this has different y values. It's just that with our limitations, we have to draw so far away that you can't see them. Okay, so in math, instead of writing out one-to-one like this, we're just going to abbreviate it like this, 1-1. So this mathematical symbol right here means the function is one-to-one like this one, where none of the y values are repeated. All right, the reason why this is important is because only functions that are one-to-one functions have an inverse that is also a function. We say that these types of functions are invertible. So that's a vocabulary word you need to write down, you need to be familiar with. Invertible means that the function's inverse is also a function. So some of the ones you guys have been doing in Delta Math, when you find the inverse is not a function. It doesn't mean that those things are not the inverse of the original. What it means is that that is not a function. The inverse thing that you get is not a function. So let's look at some examples of that. Okay, so look at this one. Here I have my original function f of x. Here I have the line y equals x. And you can see that my original function is reflected across the line y over x over here. Okay, so look at my original function. Would you say that this function is one-to-one? Let me put some horizontal lines on there. What do you guys think? Is that function one-to-one? No, the horizontal line is touching more than one y value at a time, so this function is not invertible, which means that the thing that's over here that is its inverse is not a function. You can see if I put some vertical lines on here, this blue one is not a function. So when I graphed this one in Desmos, what I had to do was, this one is a parabola. This one is an x squared. And we know that the inverse of a parabola is a square root, right? The opposite of squared is square root. So when I put this one into Desmos, I had to put it in two different times. One time for the positive half of the square root, and then another time to get the reflection down here, I did the negative part of the square root. So this is actually two separate functions put together. A positive square root up here, that would be the inverse of this half of the parabola, and a negative square root down here, which would be the inverse of this half of the parabola. So each half of the parabola is invertible. Each half of the parabola has an inverse that is a function. It's just when I put both halves of the parabola together, the equation that I get has a positive and a negative. You guys remember you had to put that little plus minus when you take the square root of something, and so it gives me something that is not a function. Okay, so look at this one. Here is my original function. Would you say that that one is invertible? All right, well, let's put some horizontal lines across it. All right, what do you guys think? Does it look like it's one-to-one? Does it look invertible? Yeah, none of my horizontal lines are touching more than one y value at a time. So if I look at my function, you can see that it is in fact a function. All of my little vertical lines only touch one value at a time. So I can use that f inverse x notation. This one, do you recognize the parent graph right there? That's x cubed. And the inverse of x cubed is cube root of x. So cube root of x is in fact an inverse function. The original function and its inverse are both functions. Therefore, this original function was invertible. Okay, so what do you guys think about this one? Is this function invertible? Is it one-to-one? Does it have an inverse that is going to be a function? If you said yes, you are correct. So here's my original function, f of x. Can you tell what parent graph that is? That's a square root graph. So the inverse of square root is square, but look, that's only the positive part of the square root graph, so I only get half a parabola when I take the inverse. So this function is invertible. It passes the horizontal line test, and its inverse is a function. It would pass the vertical line test. Okay, let's try this one. What do you guys think about this one? Is this function one-to-one? Is it invertible? If you guessed no, you are correct. If I put horizontal lines across this one, I'm not going to get something that's one-to-one. So that means its inverse is not a function. So this f of x was an x to the fourth graph. And just like x to the second, just like when we square something, when we take the fourth root, we have to write plus and minus. So here's the positive part, and here's the negative part. So this one does not work out to be a function. It would fail the vertical line test, right? You guys can see that right there. And so the blue one is not a function. The red one is a function. It's just that it's not one-to-one. So therefore, its inverse is not a function. All right, let's try one more. How about this one? Let's see if this function is invertible. All right, before I show you the answer, do you recognize the parent graph on this one? Do you know what this one is? Well, this one is exponential growth. You can see my anchor point move from 1 up here to 3, right? It's had a +2 on the end of it, but it is exponential growth. Okay, so think about this part. In an exponential graph, what's really happening here? Is the graph touching the y equals 2 line right here? No, that's an asymptote. Remember, it never actually touches the line. It gets closer and closer and closer, but it never actually reaches it. So it might look like this one is not invertible. It might look like right there you're touching lots of y values at the same time. But the truth is, because it is an asymptote, We are not. We're actually going down a little bit every time we move over. It's just that our technology, because we are not zoomed in close enough to see it, our technology can't draw that. It looks like it's laying right on the 2 when it's actually not. So what do you think? Invertible or not invertible? This one is invertible. So here is my exponential curve. The inverse of an exponential is a logarithm, which we didn't have time to get to this semester, but there's a logarithm. And again, it looks like it's not going to be a function right here. It looks like it's going to go straight and it's going to fail the vertical line test. But the truth is there is a vertical asymptote right here, just like there's a horizontal asymptote right here. So just like this one is getting closer and closer and closer to y equals 2, this one is getting closer and closer and closer to x equals 2 without ever reaching it. So even though it appears to lay directly on that line, it's not. So this one is in fact one-to-one, this one is invertible, and this one is in fact a function.